In this video, we discussed a second problem that uses recursion. It's a problem of reversing digits. So the problem is to write a short method that when you're given a positive integer with n digits, we print those digits in reverse order. So in other words, if the digits are 1, 2, 3, 4, 5, we want to print 5, 4, 3, 2, 1. So what is the base case? Again, what is the problem related to the original one of which we know the answer? Well, obviously, if you reverse a single digit. So if I tell you to reverse the number 9, you know the answer. The answer is 9. Reverse 7, the answer is 7. So as long as we're reversing a single digit, we know what the solution is. On the other hand, what happens if I give you a number that has 55 digits? How are you going to solve the problem? Well, what you could do is to apply recursion and say, okay, I don't know how to reverse 55 digits, but I can extract the last one, and I know that that's the first one that has to be printed. I can extract the rightmost digit, print it, and then deal with the problem of reversing 54. And to reverse 54, what do? We extract the last one, we print it, and then we try to reverse 53. So we're applying recursion. So if we want to write this using code, then basically what we're doing is this part. This is the base case. In other words, we're going to test the value of the integer. We're given a value of an integer, which is positive, right? Let's say if the integer 100. And then we're going to say is less than 10. Less than 10 means is a single digit. And if it's a single digit, we know the answer. It's the digit itself. There is nothing to be reversed. So if we're given a number between 0 and 9, we just simply print the number between 0 and 9. There is nothing to be reversed. On the other hand, if we have 5 digits, 10 digits, or 100 digits, how do we solve the problem? Well, the first thing that we need to do is to print the last digit, the rightmost. And how do we do that? Well, we do that by finding the remainder of dividing by 10. We're using a decimal system, so we know that if we find the remainder of dividing by 10, that's going to be the lastmost digit, which is the last one, which is the first one that we should print if we're trying to print in reverse order. And after that, what? Well, we make a recursive call. So we call our method right reversed, and we need to reduce the size of the problem. Reducing the size of the problem is using all the digits but the last one, because the last one was just printed. So how do we strip the last digit from the original number? Well, simply divide it by 10. Okay, so if I start with 123, for example, and I divide by 10, I'm going to pass 12, because 123 divided by 10 is equal to 12. So dividing by 10, what it does is to reduce the size of the problem by extracting the last digit, because the last digit was the one that I was printed. And that's the solution to the problem. So now I'm going to switch screens and I'm going to show you the code. So here I'm showing you the solution that we just wrote. Okay, so we have basically a main method that calls my method right reverse with the value 5437. So I have 4 digits that I need to print in reverse order. So what I want is what you see here in my output window. I want to print 7345. So the right reverse method, it has an if and an else part. The if part is the base case. I know how to reverse a single digit, so I'm testing for less than 10. If it's less than 10, again, that means it's a value between 0 and 9, which I know how to reverse, and the only thing that I have to do is to print digits. For the time being, don't pay attention to these comments. I'm going to use them in a couple of minutes. Now, what happens if this statement is false? Like in this case, I have 4 digits. So, the value that I'm using, 5,437, is not less than 10. Then I need to use recursion and reduce the size of the problem. But the first step is to print the last digit, the rightmost. I want to print the 7. That's the rightmost, that's the last one, that's the first one that should be printed, 7. How do I do that? By using the mod operator in Java. In other words, divide digits by 10 and use the remainder. And I'm going to print then the value 7. Then what is my next step? My next step is make the recursive call. So I'm calling my method right reverse, right? And reduce the size of the problem. To reduce the size of the problem, what I want to do is to pass everything but the number that I just printed. In this case, I want to pass 543, 543. So how do I go from 5,437 to 543? Okay, so that's simply dividing by 10. All right, so if I divide this number by 10, what I'm going to be doing is passing simply 543. And again, 543 is not less than 10. So what do? I print the last digit of 543, which happens to be 3. So far I print 7 and 3. Okay. If the number here is 2468, right? Just to show you, then I'm going to print 8642. So it worked for all sort of numbers that we want. Now let's analyze a little bit of the problem and print these comments. These comments are simply tracing the values that I'm passing, what is being printed, and what is being used as a parameter. So here we go, okay? So the initial call is with 2468, so the initial value of digits is 2468, and then this statement is false because 2468 is not less than 10. So what happens here? Well, I'm going to print the current value of n, which is 2468. Then I'm going to figure out what is the digit that I should print. The digit that I should print is the rightmost digit. And to get the rightmost digit, I simply perform this operation. Okay? I use the modulus operator. And clearly here you see that I'm extracting the 8. And then what? And then I need to use what is left. What is left? The digits 2, 4, and 6. How do I extract that? Well, by dividing the original value by 10. And here I'm telling you, okay, this is what is left. So I have separated the last digit, 8, which is the one that should be printed first, and then I make a recursive call with a problem that is smaller in size because now it's a problem that has 3 digits instead of 4. This 8 here simply tells you, oh, that's the first number that I should be printing. Indeed, that was the last number in my digit. What happens now? I'm making a recursive call, but now I make a recursive call with a number that has 3 digits, so I have 3 instead of 4. And again, test for less than 10, well, 246 is not less than 10, so I go to the else part, and again, what I'm going to be doing here is to say, all right, I need to extract, okay, the last digit, and then I need to make a recursive call with the digits that were not printed. Extract the last digit, that's 6, that's this statement here, and then strip that last digit, and that's divided by 10. And then what happens? I'm going to make then my recursive call with 24. So the next value that I use in my recursive call has only 2 digits. So I went from using the original 4, 3, 2, okay, and what's going to happen next is going to be that I'm using 24. And again, 24 is not less than 10, so I'm going to be here. So what happens? Oh, the current value is 24, right? Then the digit to be printed is the last one, which is digits mod 10, okay, which is this statement here. And that's the 4, and then I'm going to strip the 4 from the current number, and I'm left with 2. So indeed, I print 4. So far I printed 8, 6, and 4. Here, I start with 4 digits, then 3 digits, then 2 digits, and right now I'm down to a single digit, which happens to be 2. So when I make the recursive call with n equal to 2, that means digits is 2, and then this statement for the first time is true. 2 is less than 10. So what I want to do is to print the value of digits, which happens to be 2, and the last digit printed is 2, and then I'm done. So I'm going to print 8, 6, 4, and the last digit is 2, but that is correct because that is printing this number in reverse. Okay?